Good evening to everybody. My name is Timothy. This night marks the ninth day of our training on machine learning and deep learning coupled with deep learning, then with Python. I want to introduce our tutor this night in person of Ayobami. Kindly take over, Ayobami.
Okay, sir. So I'll be sharing my screen so that we can see what I'm doing. Okay. So okay, can we all see my screen? Is it very clear?
Yes, it's
Yes, it's
clear.
very clear.
Okay, good. So we are going to be looking at data tonight, how we can work with data, where we can get data, and how should our data looks like. So we are going to be looking at it tonight. So that's why tonight's class is just only titled working with data. So and we are going to look into warm up and review, and we're going to look at importance of data. We're going to look at data sets. We're going to look at where to find data for deep learning models. We're going to talk about deep learning and data and assignment and homework. Then some references of where we can get some data as the link there and some extra links to go and read up on some certain things relating to how to get data. So now the warm up and review is that we talked about deep learning and we talked about artificial neural networks, we talked about bias, and we talked about perception, activation functions, forward and backward pass, loss functions, loss optimization, and gradient descent algorithm. So that was what we talked about in the particular slide that we focused on, that we just talked about introductory aspect to neural network. So now we are moving into importance of data. So now the main requirement of deep learning is big data, and big data is what we really need. And in this age and in this era, we have access to big data. We have a lot of access to data that is very plenty. And also, part of the main requirement of deep learning is also a powerful hardware, efficient software, which we talked about. So, but basically, we are going to be focusing on big data only for tonight. So, but why is data so important? So, data helps to make informed decisions based on reality, and so it allows us not to guess. So when we say data, data has a lot of informations that are hidden there. So and when we actually try to unravel the mystery in that data, then we can actually make informed decisions. So and with data, we can tune the deep neural network parameters and create generalizable models. So, which means that the bigger the data, and it means the better for us in order to make a more generalizable models. And without a proper data, we cannot expect the model to work correctly. So, which means that when it comes to deep learning, that means that data is very, very, very important. So now, still on the importance of data. Now, the analogy to deep learning is that the rocket engine is the deep learning model and the fuel is the huge amounts of data we can feed to these algorithms. So, and which was stated by Andrew Ng, which is a computer scientist and machine learning pioneer. So, now when we talk about
Hello,
deep
tutor.
learning, yes, sir.
We can only see only one
Oh, sir.
slide you show to us. Have you been showing other slides? Because I can only see only one slide here.
Yeah,
Yes,
this
I've been showing
ah
another slide.
Please, we did not
no, it's
see
not
it.
moving. Your the slide is not moving. It's not
Okay,
moving.
let me stop.
So
Yeah, I'm coming. Sorry. Okay, can we see this now?
you can see
Yes,
this.
I think it's fine.
Is it moving? Okay,
It's
just
moving. It's
okay.
moving.
Moving now.
Sorry about that. Okay. So, like I said, we talked about the um, deep learning introduction into deep learning. We talked about artificial neural network, bias, perceptron, activation functions, feed, forward and backward pass, loss functions, loss optimization, gradient, descent algorithms. So, and like I said the main requirements of deep learning is big data. So we need a very large data in order for us to have a very generalizable model, something that can actually make prediction in reality, something that mimics reality. So for us to have something that mimics reality, we need very big data. So and the reason why we need big data is so that we can make informed decisions. And the bigger the data, the more generalizable the model, which means that it can mimic reality. So, and without proper data, which means large data, proper data, data that actually represents reality, we can't expect to have a working model. So, which means that we need a good data, a big data, a data that actually mimics reality so that we can have a model that actually can work in reality, something that will mimic reality. So now, like Andrew Ng, who is a computer scientist and machine learning pioneer, he said that the analogy to deep learning is that the rocket and is that of the rocket engine. So is that is the deep learning model. Rocket engine is the deep learning model, and the fuel is the huge amount of data. So just like for us to power up a rocket to space, so we need the deep learning model itself is the rocket. So and when we now talk about the fuel that will power it up to space is the data. So the more the data, which means the fuel, then the better and the higher our chances of propelling the rocket into space. So, which means that the more the data we have, the better. So, to have a better deep learning model. So, now, still on the importance of data, we are going to look at types of data when it comes to deep learning. So, deep learning can be applied to solve various problems. Thus, the type of data we use depends on the problem. So, the problem will actually warrant us to actually take a step to make research on okay, which data do we need for this particular problem to solve this problem? Okay, which data do we need in order to be able to mimic reality for this particular scenario? So, and general classification of the data where all those different types of problem falls under is image, video, sound, text, and time series. So now, when we look at image, which is very common, which has to do with computer vision. So now, when we hear computer vision, it has to do with trying to able to classify image, able to segment image, and able to predict image. So when we talk about if we want to create a, or let's say in the transportation sector, where we want to create a software, a computer vision software that can actually catch drivers that default by disobeying the traffic light, then we can station a computer vision software at each let's say at each intersection where we have the street lights or where we have the traffic lights or anything. So then when we have it there, So when it shows stop and the driver did not stop and he actually beats that he did not beat the traffic light and he goes, then the camera we actually snap that plate is the driver's plate number and be able to now bring out all the informations that are relating to that particular person. So because there should be a database, yes, in a working society, there should be a database for where we can actually, if you have the plate number of a car, then we should know the person's name, the person's address, where the person work, or anything, any other informations that are useful that we can use to trace the person, and we can now tell the person, okay, this is the fine you pay for defaulting this law. So that's under image. So now talking about video, we can talk about motion detection or tracking. For example, when it comes to security, when we want to have security feeds or sensors that can notify us that we have intruders in the compound, or intruder has entered inside the house. So it's more or less like having something like motion detection or motion tracking. So whereby we can able to detect if anyone crosses a particular line, or just the way we have actually programmed the model to work. So that video, when the camera will actually be taking the feed of the video, then when someone passes that side and it detects anything unusual other than the normal background that is supposed to be there, then it triggers an alarm and it says, okay, there's an intruder in this so terrain or in this environment. And it can really help when it comes to research in the military. The military can really leverage on all this motion detection and motion tracking when it has to do with helping the Air Force and the Navy and the soldiers. So now let's go to sound. Now, when we talk about sound, we have voice recognition. So how you must have wondered. Let me say some phones have, for example, iPhone. I think yes, they have this software whereby you can use your voice to open your phone. So these are voice recognition systems. So you can train your voice, or you can train a software or a model whereby it will be able to recognize a particular voice. So whereby we can say we can use our voice to open the door to our entrance, to our voice. So, and our voice is peculiar to our own self. So, which means if I don't talk to my door, so if I have a software that actually helps me open the door, any other person that says anything, I'll just say, okay, door open, and it will open. So, but any other thing apart from that, it won't open. If it here listens to another person's voice, maybe my wife's voice or my child's voice, so it won't open. So that's one thing about sound, and which is categorized under voice recognition. Also, we have text, which has to do with class reviews, classification. So now we know we have a lot of models, and in short, this actually falls a lot under large language models. When I talk about text like ChatGPT and Llama, and we have a lot of them, they are much outside there. So we can have text whereby we train a model whereby it can be able to interpret text, can be able to communicate text and give insight on anything that we want it to tell us, and give us informed information about any topic of interest. So that's about text. Now we also have time series. We'll talk about sensor data. Sensor data, we'll talk about time series like weather. So, and we have financial accounting data like that, and banking and finance, and so on and so forth like that. So that's where that one falls under. So now, in any area you want to work with, we have all this general classification of where the data you need can fall under. So that
Hello,
is
Alobami.
that about this. Yes, sir. Hello, sir.
Please continue.
Hello, can we hear me?
Please, we can hear you.
Okay.
Continue, please. It is somebody class. I've muted him.
Okay. So now we still on. We are going to talk about data sets now, and collections of data generally of the same type. That's what we need. So if you are going to train a model for or computer vision or motion tracking or anything, the data has to be the same type. And generally it must contain hundreds or thousands of samples. So they can be enormous. For example, it can be 20 gig data, it can be 50 gig data, and so on and so forth, because the more the data, the better the model. And also, the data can be generated by companies or organizations or universities. For example, MIT has a data repository. So, and we have Google. Google as an organization makes available different data sets that can be used to train deep learning models. And companies like YouTube also as well is there. So, and we also have characteristics of the data set we choose. It must be relevant to the problem. That's very important. So you can't want to solve a problem that has to do with motion tracking and you are collecting data. Instead of you to collect live feed that you need to use to train a data set, you are using a static image to train a problem that has to do with live feed, training live feed problem. So that is that about that. You must collect the data relevant to the problem. Another one is you must have adequately labeled data and accurate classification. So when we say adequately labeled data, which means that for every data, you must be able to label them and give them a unique identifier so that you'll be able to identify, okay, so this is someone that is sitting down, this is someone that is standing up. Okay, this is a dog, this is a cat. So that's where we talk about labeling. So labeling is very, very important when it has to do with deep learning models and training computer vision models. And it must be easy to assess. And when we say easy to assess means that when you want to train the model or you want to validate, then there must be easy access to the data, or it must be an open source. Or if it is not an open source, if it is let's say third party data set whereby you can't share it to another person because some people are so skeptical about leaving their data set to the world. So we must have access to it. That's also another thing. Another thing is you should have proper formatting of data. So you don't need to pre-process. So the proper format means when we talk about JPEG, if your data has to be in JPEG format, if it is image, it must be JPEG. It must not be JPEG and PNG, JPEG, PNG. No, it must be consistent. So it must be JPEG all through or PNG file all through. Yeah, if that's the case. So everything must be the same. So in many cases, data sets are not released to the general public. That is for security reasons and the reasons best known to certain organizations or certain companies or universities. An example of that is OpenAI. OpenAI, we don't have access to the data that they use to train ChatGPT model. I can tell you that ChatGPT 4.0 is actually much more better than ChatGPT 3.5 because I do use GPT 4.0. So, which means that the data that I use to train GPT 3.5 is so big that when people start using it, the amount of data the ChatGPT 3.5 has acquired was also combined with what was used to train the 3.5 and matched together to train the 4.0. So that's why we have the GPT 4.0 is actually much more accurate and it's getting to a certain level. So you can generate image, you can attach image and PDF and so on and so forth like that. So that's that about this. So most of the time you might not have access to some certain data sets, reason best known to companies and organizations. So now we want to look at some examples of some data sets. There is a particular sample which we call the MS Cocoa data set. And what is the type? The type of the data set is an image. Oh yeah, MS Cocoa data set, and the size is 25 gig. And The number of instances it has is 1,500,000 images, and it has 80 different classes, which means from car, and the example is from car to train to cow, dog, persons. So it's just like almost data set that has to do with things we see in everyday life. So, and it is perfect for object detection. If you want to train an object detection model, or you can use it, and it also contains captions as well. So, when you want to actually train a model that has to do with uh, object recognition, so you can actually use the MS Coco data set. You can download it, but for this file, it is too big, very very big. If you have the data, you can download it. So now, for you to download it, this you can go to the www.cocodatasets.org. So you can get it from there. So, and let's move to the next one. Next one is the ImageNet dataset. Now, the ImageNet dataset is the type of the data is an image, and the size is 150 gig, which is much more bigger than that of the MS Coco data set. And the number of instances is 1.5 million instances, and it has 1,000 classes. So different things, 1,000 labels, which means varying from anything you can ever imagine: baseball bat, wheel, shield, windscreen, anything at all. It has it. So one up to 1,000 labels, and it's perfect for object detection, and it contains bounding boxes. So we still talk about bounding boxes as well. So that's for this. So for those of us that are saying how can we get data set? So this is it. Another one is the open images data set, and it has to do with image, and the size is 500 gig, and the number of instances is over 9 million instances, means over 9 million data points, and the number of classes is not specified. So for more information, it can actually do, it's perfect for object detection, and object detection, image classification, and visual relationship detection. So if you want to train a model that has to do with object detection, image classification, you can use the open images dataset. So, but mind you, you have to use, when we were talking about uh, the the things that we need when it comes to building deep learning models. We talked about the system specification, hard drive space, and a lot of things like that. So, because this is half of a terabyte, so if you can download this, that's half of a terabyte. So that's pretty much. So let's move to another one. We have the CIFAR 10 data set. This one is much more light, not heavy. So it is also has to do with image, and the size is 170 MB, and it has 160,000 instances, and number of classes is 10, and it contains various objects which can use for object detection. So that's for the CIFAR. And most of the time, people use this CIFAR for training object detection model because the size of the image is not much, 170 MB. So that's for that. So now we have the MNIST dataset, and it has to do with the image. And the size is 50 MB. And the number of instances is 70,000. And the number of classes is 10. And it contains handwritten digits. So when we want to do prediction on writings, like for example, what we want to classify, okay, a certain writing, okay, is this one, is this two, is this three, is this four or not? Because I will use this as an example for us to do prediction of a number. So when we write a number, we use any number. After you have trained it, you can write different numbers ranging from 0 to 9, and it will be able to predict and tell you that, okay, what you have written, it is 1, it is 8, it is 7. So that's for the MNIST data set. So now we have YouTube 8 million data set, 8M data set. Now, this data is video. So that's why you have to do motion tracking, object tracking, and so on. The size is 50 gig, and the number of instances is 6.1 million, and the number of classes is 3,862 classes, and the total length is 350,000 hours. And for the more info about it, it contains short video clips with high quality annotations. So if you want to do anything that has to do with um, face tracking, um, tracking objects, then you can use this data set. Also, we have the free music archive, which is called FMA dataset, and it has to do with sound. And the size is a terabyte. The number of instances are 100,000. And the more information about it is that it's used for, we want to do proper music analysis, or it contains tracks, metadata, and genres. Yes, hello,
Yeah,
any question?
I don't think the pages are changing here. I don't know if it's from my end. I can't see the next page.
It is from your end. The recording is okay.
I'm talking about
Okay,
this.
can everyone, hope everyone is seeing, okay, the FM data
Sample
set.
free
Yes,
sample
yes.
free
Okay,
music archive data
Very
set
well, very well.
FMA. So we can see it
okay.
here.
Yes, I can see it here, sir.
Okay, boss,
It needs
proceed. The recording will elaborate
Okay, sir.
more when you are going through recording.
So if you want to do anything that has to do with music analysis, and we can actually leverage on this data set and use that to train a model that has to do with sound. So another one is the ballroom dance data set. So this also has to do with sound, and the size is 14 gig, and the number of instances are 698, and the duration of each file is approximately 30 seconds. And for more information, it contains ballroom dancing audio, so which means it has to do with just basically sound. So we want to train anything that has to do with sound, so we can leverage on this. So now another one is sentiment 140 data set. Now this type of data has to do with text, and the size is 80 MB, and the number of instances is 1.6 M, which means 1.6 million, and it has to do with text classification for sentiment analysis, and has to do with Twitter data. So when it comes to sentiment analysis, you can use these data sets. Basically, when it comes to, I just want to chip this in. I don't know if there are a lot of people that are actually into sentiment analysis, and sentiment analysis can help us with gaining information as pertaining to a particular subject matter. For example, I saw a publication on sentiment analysis of NSAS. I think NSAS was during which year? I think 2020 or when it happened. NSAS, NSAS protest. So they did sentiment analysis, and they were able to narrow down using some hashtag on Twitter to actually narrow down to informations that are needed, and that shows ground truth about what actually happened during the NSAS. So that's sentiment analysis. And sentiment analysis can be used to actually predict who will win the next election. Okay, who is going to win the primary election or governorship election. So sentiment analysis is so diverse and can be used for a lot of things. So, but it depends on the data. So, but a lot of people go to Twitter to get their data from there by what? By web scraping. So, and using the data for sentiment analysis. So let's move on. Another one is a large movie review data set. And this has to do with text, and the size is 80 MB. And the number of instances is 50,000. So for more information, it has a binary settlement classification and polar movie reviews from IMDb. So if you want to actually give reviews about movies, you can use this data set to actually leverage on giving reviews on movies. So we have the minimum daily temperatures data set. The minimum daily temperatures data set, it has to do with time series. So time series data, and the size is approximately 70 kilobytes. The number of instances is 3,750, and it contains temperature data over 10 years in Melbourne. So I don't know. I think we need to. I don't know if we have a um, national archive for temperatures for Nigeria. I don't know, or maybe Lagos State, or Osun State, or your state, or Abuja, for duration of 10 years. I don't know. So someone can leverage on that and be able to actually train a deep learning model and be able to predict um, temperatures for the next 5 years, next 10 years, and so on and so forth, like that. So that's for temperatures data set. So now we want to now compare two things. So now there's a difference between standard data and real world data. Now, when we talk about standard data, it is great for academic works. Clean data that is already classified into balanced categories. It is collected in standard and normal conditions. It generally can help us in the pre-training stage or may trick the deep neural network in some scenarios because it just look like that standard data is not actually capturing reality, so to say. So, but if we want to just use it in some certain cases whereby we want to do academic works, so we will leverage on standard data, so which makes our work much more easier and faster. So, and there are some things we need to actually take note when we are using standard data so that we will not fall into some potholes. So, now let us now compare real world data. Real world data are always messy and they have variation and they are always evolving. And it is collected from various sources in standard and challenging conditions. It is perfect for practical usage and deep learning solutions. It needs pre-processing. It needs labeling or annotation in supervised approaches. You see, the real world data captures reality. And when we want to give a very, very accurate uh, model, a model that's actually between 97% to 99.9% that mimics reality in that range, we need to collect real world data. But the cost of collecting real world data is very high. So if it doesn't have to do, that's why we need um, I don't know if we have a deep learning society in Nigeria. Maybe they can advocate, maybe liaise with the federal government or bodies that need to be liaised with, so that there can be access to such things and we can use it to solve a lot of problems, like problems that has to do with kidnapping, insurgency, and so on and so forth. If we have real world data as pertaining to that, and this machine learning, deep learning can create AI solutions like that to solve the problems. So that's pertaining to real world data. So real world data is very, very good, but when it comes to academic works, we use standard data. So next one. Now, when we talk about standard data and real world data, this is what we mean. If you look at this, these are standard data. You see it. They look too standard. Is that not it? So, but now, if you look at real world data, do you see different scenarios, different cases? They have to be labeled. You can see because they have backgrounds. So we need to differentiate them from the background. And which is this? You can see this, you can see in different cases, collected in different conditions and different scenarios. So this is real world data and this is standard data. So now when it comes to audio as well, if you look at the standard data for audio, you can see the way it looks. Now the standard data doesn't always have background noise. It is already cleaned, it's already standard. So, but in the real world case, we have something that they call what background voices. We're hearing some echoes and everything, unwanted noises. So that's real world data, and it's very good in order to what to be able to segment voices, or we want to do audio analysis to filter voices out and separate voices, voice analysis, and so on and so forth. So there's a difference between standard data and real world data, which is this for audio, which you can see. Now, how do we generate data? Collecting data might be needed in some cases, depending on the problem we are trying to solve. So, using various sensors like cameras, sound recorders, thermometers, etc., which actually can be useful in collecting data in the certain cases that is needed to solve the problem we are looking at. So now there's something called data crawling. Data crawling, it is helpful when there are no public or accessible data sets. When we don't have any access to public or accessible data sets, we can use data crawling, and it has to do with the automatic collection of data from websites using web crawlers. So, which means that we just download it from the web and it just comes to our system. And basically, part of that is web scraping, which is mostly common. And there are other means and aspects which look we will still look at. So now, we want to ask some questions, still under how to generate data. But why need real world data? That's the question. You see, these are questions that need answer and clarification. Why do we really need real world data? It is to make a practical applications. Now, practical applications in the sense that if we use standard data we can doesn't actually relate or equate absolutely to reality. But when we use real world scenarios, real world data to train a model, then it can mimic in practical, it can mimic reality. So that's one reason. And also to find out how the model can perform better, how the model can equate to reality. There's also to make sure that the model cannot be tricked. So for the model not to be tricked, we need to use real world scenario, real world data, and also to understand how the model can make wrong predictions. So when we are dealing with real world data, it actually helps us to know if the model our model can make wrong predictions, which will be much more something that we can leverage on and still enhance the model. Now, how much data do we need? That's the second question. The minimum requirement depends on the problem we are trying to solve. That's it. So the problem dictates the amount of data and the type of data. Now, still on how to generate data sets, the third question is, what about rare or scarce instances whereby it is very scarce or rare to actually see such scenarios and or it's scarce to record or capture such data. So it means that we need to balance the classes, and also we need to collect more data, or sometimes if it is not possible due to cost, accessibility, or time. The second approach is to do data augmentation, which means increase the amount of data by adding modified copies of existing samples. And or we can do sample techniques like flip, rotation, we can crop it, or we can scale it. And now, an example of that is this. We can flip, you can see rotation, flipping, and these are what we are talking about, cropping and scaling. That's when we have rare instances or scarce instances. These are things that we can do. Collect more data. So, but if there is cost can be incurred, or we waste our time or accessibility, then we can do data augmentation by flipping, rotating, crop it, or we scale it, or we add modified copies. So that's that. Now, fourth question on how to generate data set. How to prepare a generated data set for training. How do we prepare a generated data set for training? Number one, we need to clean the data as much as possible. When we say cleaning, it means removing outliers, missing values, low quality samples, duplications, etc., etc. Blurry images, images that are not captured under good lighting conditions, we need to remove them. They can't help us. So now, collected data should be cleansed, standardized, and de-identified. So, which means to prevent any personal identity from being reviewed. That's why we need to clean, standardize, and de-identify it. And also, always consider privacy issues. Now, there are some ethics that has to do with data collection. So, and Europe and in United States, they take this very serious when it comes to privacy issues. You can't just go ahead and start snapping people. Just normally, some people in Nigeria here, we don't follow some ethical rules that has to do with collection of data. We just go ahead, go to the field, just snap, take images without people's consent, which someone can be sued if we are in a working society. So for someone not to be sued, you need to go through the normal channel and organization bodies and to collect approval for you to collect your data. That's that. So now we also have to separate data into their proper classes, which is labeling. So we have to add labels either by manually or automatic labeling. That's that. So
All
now
right. At this
another
point,
thing.
hello. At this
Okay.
point, I think we need to pause for 1 minute because our time for this link is almost lapses. So we have less than 3 minutes for this area to this link to lapse. So you can say something within that 3 minutes. So now give us another link so to join again. So can you continue for the next 2 3 minutes?
Okay. Okay. Do we have any questions so far? So good.
Are you done with the
Yes,
general side? Are you done with that?
Yes. Yeah, I'm done with that.
Okay.
So if there's any
I will
question,
raise my hand.
You have been raising your hand. I've seen your hand being raised. I will call you to ask a question.
Yes,
Probably let me give you the link out now so that we can continue from here. Okay. On these notes, I think we can welcome questions. So, Mr. Rajide, please, your question, please.
yes, thank you very much, sir. And our teacher, I want to really appreciate what you have been putting up for us. But I want to speak in the aspect of the data space.
okay,
Um,
sir.
like in my own field, accounting, we usually deal with panel data. Although sometimes we do use time series, but then basically we do use panel data. And then I observed that panel data were not among the ones we listed. So what can you do or how can we do with respect to the panel data? Thank you.
Okay, sir. So as regarding that, I want to talk about how it depends on how the panel data looks like. If it is in terms of numbers or in terms of writings. It depends on the appearance, so that will determine. But as far as I'm concerned, if it is a text or if it is a number which is numerical, so and deep learning will work. But it just has to do with when you collect all the data. We need to now sit down and look at the way the data looks, how it appears, and what we can use it for. So that's just the thing. But it's not my area. So what I actually deal with most of the time is videos, image. So that's what I deal with. So
Yes,
I'm not conversant with that area. But if I can have a look of how it looks, what I've heard about panel data, but if I can see how it looks, how it appears, then we can say this is
Okay.
the way we can go
To
about it.
corroborate with what you have just said, parent data is a combination of processor data and time series data. So when you combine time series with processor data, that will now become parent data. And it is of two types. We have dynamic, we have static. When we talk about parent data, let me give a very good example. Example is when you are having to combine probably like 5 countries, data set of 5 countries, and you now combine what is happening in those 5 countries together, and you cut the data in terms of with time interval, probably on monthly basis or yearly basis. So that means you have considered the time series. You have also considered processional part of the data set. So when you combine both together, then it becomes panel data sets. So that is what is called panel data sets.
panel data.
Yeah.
Yes, that's very correct. So they are usually in number. So even
Numbers.
the like the
Okay.
example Dr. Singh gave, those five countries could be represented in terms of numerical value. You can see country Nigeria one, South Africa two,
That should
another
do.
country three.
Then, if that is the case, then deep learning will work. That's the label actually, because you need to
Yes,
label the data as a unique identifier. So if that's the case, and it will work. So maybe I don't know. Maybe when you want to start your work proper. So if I can have a look just to make suggestion along the line, so I'll be able to render any help I can render. So as pertaining to
yes.
that, depending on the type of architecture to use for such.
Okay.
Yeah, another person,
Okay, sir.
Mr.
So
Hakim, your question, please.
Good evening, everyone. Good evening, facilitator. I
good evening,
actually
sir.
have two questions, then, and I'll be very brief with it. Firstly, I wanted you to differentiate between image data and video data. That was exactly when you are treating the two topics. Then, secondly, I don't know how will you categorize scanner that is being used at our shopping mall. Thank you.
Okay. So the difference between image data and video data is this. Now, when we talk about image data, for example, if you take your phone and you snap an image, you know how it looks like. So it's just static. It is just there. So it doesn't move. So then for video, you can capture the moment whereby things are moving, both where we have things that are static and things that are moving, and showing gestures, smile, and all other things like that. So now the two difference there is that one is static, one is dynamic. So, and in the case of images are used for example, like I said, object detection, face recognition. When we want to recognize someone's face, facial recognition, then we can use that. We can use images for that. So, and even if the person we use a video or a scanner, or we use a camera and place it in front of the person. As far as we have used the person's image to train the model, it's able to identify that okay, this person is uh, Tamedo, this person is uh, Tom, this person is James. So it's able to identify that. But one thing about video is this: is that video, in the other sense, is used for or something different from images, whereby when we want to be tracking movement of something, motion sensor, motion tracking. So that's when video is actually much more applicable. We can't use images to train models that I want to use for object tracking and image tracking. So you can't use images. So you use videos. So videos whereby in the cases whereby you have the person moving or objects moving or the instances you want to consider moving. So you can be able to track it and be able to generalize, okay, if I raise my hand up like this, for example, gesture, or let me put it this way. There are deep learning models that have been trained to interpret as someone is for deaf and dumb people. Maybe you are watching the news now. So you are watching the news and you want to actually we want to actually be displaying what the gestures that the person that is interpreting to the deaf and dumb people what the gesture want to be showing it as a text on the screen of the television station. Then we can train a model whereby we train the hand. So if it shows hand, if my hand is, there are some gestures that will show the hand that will say, okay, go, come, okay, take, I am sorry.
Yes.
There are gestures like that. We can train all those gestures. So, and the way to train the gestures is by using videos, so that when the hand is moving, so you label it at that point and annotate that this gesture means this. So anytime we now do that type of gesture again, it automatically be able to recognize that this is this gesture. Okay, this is what it means, this is what it doesn't mean, this is this is that. So that's just the difference between image and video. I hope I've been able to
Yes,
clarify.
yes. Honestly, you really good. Thank you.
Okay, sir. So the second question, you said scanner in the shopping mall. Is that not
Yes,
what you said, sir?
yes. That's what
So
I said.
okay, scanner, it can be used for two things. It's either it is used for example, like we say object tracking or motion tracking. If we want to be able to know if someone is shoplifting in a mall, we can create a model. So when someone shoplifts, there should be a line that when how do we say it, a type of gesture where someone shoplifts and maybe wants to hide it inside a bag, not put it inside the basket, you understand, or the trolley where it is visible to the eye that okay, the person really wants to buy this thing, then it will be able to signal the security, those people that are the security feed, because you might have different angles, different displays, and different screens for different corners and angles in the shopping mall. So, and one person or two persons or three persons cannot actually see that. So when we are not robots, we are not omnipresent. So, but with the help of deep learning model, we can be able to do this, that it senses that okay, if somebody shoplifts, someone put it in his bag, put it in his pocket, or put it under his clothes or anywhere at all. It will actually trigger a type of warning and be tracking the person as the person is moving. The tracker will just be on the person. So if the person shoplifts, if there's this type of gesture you make, you put something, you shoplift and keep something under your clothes, in your bag, the tracker keeps following you, and you will be able to identify you wherever you are inside the mall. So you just keep identifying your face till you get to the entrance, you'll be able to go. So we can identify the person. So we can able to tell those that are there in the shopping mall there, because there will be a camera room. So they'll be able to tell them the person is in so place in the mall. So this is the person wearing so clothes, this and this. So that's one case. Another one is image recognition. So we want to recognize images, we can use scanner. But in the case, most cases in the shopping mall, that's a practical example I've given: shoplifting, trying to solve a problem using deep learning. So I hope I have been able to clarify something with
Yeah,
that.
yes, yes, yes.
Okay,
Thank
sir.
you, Arivami.
Yes, sir. So is there another question?
Dr. Samuel Dunia. Samuel Dunia. Okay,
Thank you.
Doctor.
Thank you very much. For good evening, sir. I'm good evening to another.
Good evening, sir.
Now, my question goes like this. We're talking about sets, acquiring data sets. On machine learning,
Yes, sir.
we saw that we can acquire data sets from Kaggle. Can
Yes.
we also access or get these data sets from Kaggle on deep learning?
Yes, sir. We are still going to get there. So we are still, it's part of the thing. I will show us where we can get different data sets from different websites and platforms. We'll still talk about it, sir.
Okay, okay, sir.
Yes,
Thank
sir.
you very much.
Cargo is one of it, which you can get deep learning data sets.
Okay, Dr. Mrs. Abel Adiosun.
Yeah, thank you very much, the tutor and the organizer. I sent a material to the organizer today. I'm very much interested in some financial models, and I don't know if the tutor has knowledge in that field of some financial models where prices or maybe time series values can be simulated from some mathematical models and be used for and be used in a case of deep learning like this or some other related fields? Thank you.
Anyway, the question you ask here is somehow strictly personal and does not have any correlation with this deep learning. The reason why I said this is because what you sent to me today was purely on area of the area you needed most, which is your research, your personal research,
Yes,
and that is financial
yes,
mathematics.
yes.
So, and this is deep learning. You can see that the correlation is a little bit distant because what you sent to me today, when I went through it, I noticed that the textbook you sent to me, there are some topics you're supposed to have known before you even get to that financial mathematics, which you have not known. So it means that you are not on the same page with these people here now. So that question is not in connection with what you are doing at the present moment because the tutor does not have access to that textbook we sent to him.
Mm.
Okay, so in addition, when it comes to financial data, so we can use deep learning. So it depends on, like we said, number one, when we want to solve a problem, we need to outline what is the problem, what problem are we tackling. We note it down. And after we note it down, now we need to now talk about what solution do we want to profile. So now in the solution we want to profile, then we'll be able to list out the type of data we need. You get what I'm trying to say now? How to acquire the data. So as far as there is data, then you can build a model using machine
Okay.
learning, using deep learning. So that's just it. So it just depends on what you want to solve, the problem you want to solve. And if you can get enough data, more than enough data, big one for it, so to train. So if it is financial model for a state or a country or anything, it could be for the banking sector or whatever it is. So as far as there's access to data, and we have some objectives to satisfy, then that's possible.
Yeah, thank you
I
very
hope you
much.
get that now. Okay. Okay.
I get what you are saying. Maybe like Dr. Tim said, it's a personal issue. If I can get across to you, then we'll discuss more so that we don't waste much time here.
Okay. Is there another question?
Mr. Ayo Ajayi, I think you are raising your hands up.
Yes, thank you very much, sir.
All right.
Thank you very much, Victor. My question has to do with use of deep learning in a medical or clinical setting. I am interested in tuberculosis or lung cancer. So,
Okay.
how can I go about it? Thank you, sir.
Okay. Tuberculosis and lung cancer. Okay. So
Yes.
when we talk about, is it to diagnose,
So, yeah,
a model that
diagnosis.
can
Okay.
diagnose, right?
Yes. Yes.
Okay. So now, if we are talking about a model that can diagnose, now I want to ask a question because you are much more in the medical field, and I've actually worked on some data that has to do with medical data sets. Now, when we want to diagnose tuberculosis, how do we know how that someone has tuberculosis? Is it through scan or through some certain numerical values or what? Is it through
Uh,
X-ray or whatever it is? So that's one thing. That's one
okay.
thing. So is
Okay.
it does it have to do with image
Okay.
or scan?
Image is just one of them. But
Okay,
even before it gets to the level of image, there are some preliminary tests that are usually done before image is recommended, like polymerase chain reaction, like a blood sample. They collect the blood sample of the patient to check the medical history of the
okay,
patient. There are some preliminary tests that are done before X-ray is recommended.
okay.
So
So
and
now
and
apart
most
from
times,
okay, I'm
Okay,
listening.
and
I'm
most
listening
times,
before I come in.
okay, and most times when X-ray is recommended, is used to complement the existing tests that have been done so far. So
Okay.
X-ray is just used in combination with other tests.
Okay. So now with the test and the X-ray. So now if we were to use the X-ray as a standalone,
Yeah,
is does the X-ray actually always based on, I want to ask this question, does the X-ray actually shows most of the time that this thing is tuberculosis, or is there a way that this person has to, apart from the test, when if we take 10 people now and
yeah,
we do X-ray, and
yeah.
okay, out of the 10, let's say 6 has tuberculosis, so and
Okay,
4 does not have. So is there always a distinct difference between those 6 X-rays that I have and those that do not have, the 4 that do not have?
okay. Yeah, the idea of that history is that at the advanced stage of tuberculosis, the symptoms they show is similar to pneumonia. That's the pneumonia is when the lungs is filled with fluid, and the X-ray
Okay.
will pick that. The X-ray will pick that.
Okay.
So
So that's for the
yeah,
advanced stage.
at the advanced stage of the disease. So
So
the X-ray is
is it early diagnosis we are dealing with, or I don't know if it has stages, because now that's
yeah.
where we need to define the problem now. So these
Okay.
are things that needs to be identified so that someone will not go and be
Okay.
stressing himself and
All
doing this.
right.
So is it early stage diagnosis or middle stage diagnosis or advanced stage diagnosis? So those
So
are the things.
actually,
And what are the
okay.
things that are needed for the early stage diagnosis? If it
Okay.
doesn't need X-ray or it's just only some tests, how can we
Okay.
have access to different people that have tuberculosis for maybe over the period of 10 years or 5 years, or for data in a hospital, so we can build a model whereby when they are done with the test, we just subject the text into the model, and it's from what we have trained to be able to tell this person have tuberculosis, okay, stage this or stage that, if that's
Okay.
applicable. The
Okay.
middle stage diagnosis, if it has to do with the test and the X-ray complement, there's a way to match the two using deep
Okay.
learning and to get this in. Or if
Okay.
it is advanced stage, which means maybe some other test or only X-ray, then we build a model for advanced only. The one for middle one,
Okay.
we build that separately, and the one for the early stage diagnosis, we build that. I hope you got what I'm
Okay.
saying.
I understand.
Okay, so
Thank you,
that's
sir.
just that's just it, sir.
All right.
Okay, sir.
Okay.
Do you have another question from the house? Anybody else? Another question, please. Okay, there's no question. We can proceed. Ayobami.
Okay, sir. So we are going to go to what I call data annotation, which is called data labeling. So now, when we talk about data annotation and labeling, what does it mean? So it means categorizing and labeling of data for AI applications. Now, what do we call AI application? Now, in the sense whereby we build deep learning models and we deploy for people to use, or we commercialize it, or other people have access to use it. That's when we call it AI solution or AI application. So in the case of let's say brain tumor, or detection of brain tumor, we can't just build the model. And if I build a brain tumor detection model, do I want to use it for myself? No. So it's for the betterment of the larger populace. So we need to deploy it, whereby is either we host it on the website, or is hosted on the API of the hospital or the front desk of the hospital, and whereby anyone that is done with an MRI scan can take it there, and the MRI scan is going to be passed into the model in form of image that it was being trained. Then it can be able to predict, oh, this is what this is a brain tumor or the person doesn't have brain tumor. So there's one thing about it. But part of it is trying to label each instances that is needed to be passed into the neural network. And also providing naming conventions that describe the data also is also needed. So when we want to put conventions, if we want to label cat, this is cat, dog, this is dog. And it can be done manually or automatically. I have done some manual annotation before, and I've done some automatic annotation as well. So, and it's is the essential factors has to do with specificity and accuracy together. So, and the reason is that for our model to be able to predict accurately and to be more specific, that's why we need annotation. Okay, this is a dog, this is a cat. Okay, this is that, this is A, this is B. So that's the reason for that. And the output of the annotations can be in a JSON file, JavaScript um, notation, and it can be CSV file, or it can be in files containing marked images of video, sound. It can be in some in TST files. It can be in some other extensions like YOLO V8 and YOLO V5 and so on and so forth. And we have some list of tools for annotating data, so which we can check this website to see some of them, but we're going to talk about them. Now, data annotation and labeling. Now, we have type of data. Now, we already talked about this type of data. We said image, video, sound, text, and time series. And annotation sample. The annotation sample is peculiar to image is drawing a bounding boxes or polygons or 2D and 3D points, etc. But the one that is most common is bounding boxes and polygons. These two are very, very commonly used and which you will still look at. Another one is video, adding tracking data, etc. This one is much more common, adding a tracking data. Sound, transcriptions of language, intonations, and non-speech sound. Those are the samples or the annotation samples as peculiar to sound. And we have for text, we have tagging important keywords, titles, headlines. So this one is used for training large language models. So another one is a time series, which has to do with time labeling and time stamp, etc., etc. So these are the annotation sample that is peculiar to time series data. So now, let us still talk about data annotation and labeling. Now, when we talk about image, this is an image, for example. Now, an image always uses bounding box. If you look at this is a person here. So this is a bounding box. Now, this is polygon. This polygon is used to highlight and annotate out the car itself. You can see. So, and it's able to predict that it is a car or this is a person. And also we have a video as well. A video, we are for you to annotate a video, you annotate frame by frame. You annotate frame by frame. That's video annotation, which means video annotation is much more tedious than image annotation, because for the video you have to annotate frame by frame or label frame by frame. So another one again is about the time series. You use timestamp. You can see as it is shown here. Use timestamp, which shows the time here. So these are just instances of what we are talking about. Now, we're going to talk about some data annotation tools. We have the label box. It is a simple and powerful tool for images. It can be used for classification, object detection, and image segmentation. You simply draw bounding boxes using pen tools. So this one is part of it. I will tell you the ones that I use, which you are going to use for this class. Don't get to that point. So I will tell you the one I use. These are the ones that you can see online. So we have Make Sense, which is free, open source, and web-based. It supports multiple image annotations, including points, bounding boxes, and polygons. And it can be exported in different formats, which include CSV, JSON, XML, YOLO, and etc. And mind you, YOLO is used for data annotation most of the time because it's very effective when it comes to segmentation, object detection. That's why we use Zulu most of the time for annotation. So you have DLabel, which is a free image and video labeling tool. It provides a web-based annotation interface. It's a great tool for adding track data labels, which is for video and high quality annotated data. We also have the Decano, which is an open source text annotation tool. It's practical for sentiment analysis, named entity recognition, and also text summarization. If you want to build let me say, for example, now, if you want to build, for example, let's say a plagiarism checker, or let's say um, something that detects AI detection, words or anything, we can use large language models, which we can. There are large language models is basically on that side. So, but actually, is much more deeper than this place. Yeah, or it's just part of it. Yeah. So, if a university can build their own software that can be checking for plagiarism, AI detection, and all those stuff, but it will take a lot of resources to build such and money. So, and also we have Light Tag, which is a text labeling tool for natural language processing, which is NLP, and it's easy to use with lots of features there. So another one is where can we find data now? Where we can find data for our deep learning models. Now, we have the Google's data set search engine, which when we go to http datasetsearch.research.google.com, you can see that, and which is basically shown here. Okay. This is it here. So we can search for any data. So if I say food, like I say fast food data, so I can look for fast food data, and it will definitely give me, you can see, which is showing me, say I can go to data world or I can go to cargo. I hope you can see my screen, right? So it gives you access, you can go to data world or cargo, anywhere you can go to download, which is always in zip or CSV. You want to download the data. So now let's go to another one where we can get data from cargo. Yeah, we can get data from cargo. One of the best ways to find data is cargo, and it's the leading platform for data science. We have lots of great features, or it has lots of great features for data scientists. So you can see a lot of data to use for deep learning models. Also, we have Data World. It's also another great service to get access to public data sets. It has excellent user interface integrations and tools, which this is the website to access that. Now, where can we find where to find data? Other places are UCI Machine Learning Repository, Lionbridge AI Datasets, Sen Open Data Portal, Amazon Open Data, Microsoft Azure Public Datasets, Awesome Public Datasets. These are other places. So you can search them and check them. So now, we have deep learning and data. Why do we need data in deep learning? Number one, to train the deep neural network and fit the model. Number two, to validate the model and provide an unbiased evaluation of it. Number three, to test and evaluate the final model if it mimics real world scenario. So an example of that is this, is that we're going to split the data, tune the model, and evaluate. So which are the three steps. So now, still on deep learning and data, training sets. We have a subset of the data sets used to train the deep neural network, which are the learning stage, aka training data. It contains all the observations that the model needs to learn. So the deep neural network adjusts its weights and biases using the training data. And a pre-training stage might be needed in the deep neural networks, whereby the training data should follow a general probability distribution and cover all variations of required data. That's for the training set, which we still go into when we want to do practicals. Now, we also have validation set, aka development set or dev set, a sample of data held back from training for frequent evaluation, used to cross-check whether the model is correctly trained or not. So we can recheck the training process and the algorithm in case of low accuracy. So it should follow the same probability distribution as the training set, and it's commonly used to do what? Decrease the probability of overfitting, because we don't want overfitting in our model. We don't want our model to overfit, that's over generalized. And also it evaluates the error function and check the deep neural network parameters, which we'll talk about them soon in the next class. And the test set, it contains unseen data. Data that has not been seen in the training process. It is used to assess the performance of the deep neural network. It's independent of the training data set, and it should follow the same probability distribution as the training set. So there's something they call holdout, which is isolating a part of the training set for test evaluation as the test set, and do not use them for training the network, which is, it is called holdout, just having some part of the data which is unseen. So we use it to feed the neural network, the model, so we can see maybe it performs better or not. So let's put them together. Now, we have training and testing. Now, that training and testing is further split into what we call training, validation, and testing. So that training, we have training and validation, where this data is used to train, and this validation is used to check over time if the model that is being trained is actually not overfitting or underfitting. And this connotes the size of the data set. Now, data set split ratio, it considerably depends on the amount of data and our model. So where we have to use cross validation, where we split the data set into two, which is train and test set, and we randomly choose some percentage of the train set as the validation set, like we have seen here, which we can see in this case here, part of it, of the training set. So, and a popular approach is using the k-fold cross validation, which is very common in deep learning. And also, if we put them together, we have the training set. The training set runs in training the data, and it's been evaluated, and it adjusts the variable, and it keeps going in circles like that. And when it now goes to the validation, we run validation on the data and evaluate to see whether new variables are being predicted considerably, and it doesn't overfit, and it keeps going that way. And then we go to the point of testing to evaluate. So now, if we see that the evaluation is not okay, it means we still have to go back and add new attributes and adjust the variable and retrain, evaluate. We do what? Run validation data, evaluate, and if we test again and we see that it is okay and it actually gives us what we want, then our model is ready. So that's all. So our assignment is going to be, we still talk about it, find your field of interest. Find an appropriate data set for the subject that you have chosen, and let me know about your choice and discuss your ideas for using the data set. That's the assignment. And okay, these are some web pages and articles you can use to go and do some further read up and make some more research. So if there's any other questions, we can ask now. Thank you very much.
All right, thank you very much. Any question from the audience, please? Any question, the class?
Yes, sir. The link, those link that.
You will see the link when we share the PDF with you. We are going to share the material with you, so you will see the link. Any question, please?
Hello, hello, moderator, sir.
Okay.
Can you hear me, sir?
Yes.
Yeah, it will be fine if you organize all these videos and the codes, the links and everything into a folder, and then we send. You have our emails, and you email them to us using WhatsApp platform to share information as important as this is not effective because messages pump up there every second. Not everybody is able to pick all of them like that. So it would be nice to organize them so that whenever anybody wants to use them, the person will just go to his folder and use whatever he wants to use than the way we are doing. It's actually making some of us not to get most of the things that are going on. Yeah. Okay.
Another question? Okay, Madam Bimbola, your question, please.
Okay, yes, sir. Thank you for the lecture and the moderation. Sorry, I just want to find out, just to follow up on Mr. Ajayi, I think we're on the same page, Dr. Ajayi. I'm from medical or STEM science or sciences that deal with biological data. And sometimes we do diagnosis. And most of the diagnosis we do preliminary tests to check the persons and all that. But some of our data are in form of not images at the initial stages, but they are in form of numbers that's at the early stage, but at the late stage they can come with images. So how do we deal about it? Because one of my objective is to look at the diagnosis, checking deep learning for early diagnosis of maybe cancer of tuberculosis, like the one he said tuberculosis is talking about we do the test first on women before we can even confirm. So how do we go about it using deep learning? I don't know if you understand my question.
Yeah, I will get the question. So about the question you asked, I must deeply say that when it comes to the medical field, deep learning is seated in medical area. And this question you raised just now, like told Dr. Ajayi, I said that when we are trying to provide a solution using deep learning, it depends on the objectives. Like you said, if it is early stage diagnosis,
Or biomarker, identification of biomarker genes.
okay, so if it has to do with that, so it has to do what are the relevant data that are peculiar to such scenarios. So those are the things we need to consider. So because in some cases whereby we don't need images or images might not be needed at that point at the early stage and where the data just only comes in numerical form. So that one is something that is different or other than maybe where we move into the more middle stage or advanced stage there like that where we now need images. So using the for early stage diagnosis, if there is no need for images, then we can make do with the data that we use for that is where the data we collected for the diagnosis, we can use it to train a model, and whereby when we get data on same data from another patient, we can use it, pass it inside the model, so and we can get what we want. Okay, this person, okay, has tuberculosis, and this is maybe the percentage of social pathogens that is causing it, or this and that. So it just depends on the objectives. So I hope you get what I'm trying to say, man.
Yes,
So if it is
because
much more advanced stage, then we focus more on images, because images tend to be much more effective when in the medical field when it comes to the diagnosis. So if I'm
okay,
not mistaken,
yeah. In
so
terms of
that's
the image you are talking about, sorry, do we get all those data on the websites you gave us? Because and then what is the ethical thing
considerations.
situation around it?
Okay, now when we talk about public data sets, there is no ethical this thing, consideration. It's public, so you can use it to do anything you want to do. So, but in the cases whereby, let me just put it this way. See, in the case of trying to get a deep learning model that predicts tuberculosis, we need data sets from a teaching hospital. For example, UCH or LASUT, or teaching hospitals that have data sets over the years, like for more than 15 years or 20 years. If someone can have access to such things and leverage on that data, someone will build a solution that is much more effective. But you using a data that is public, you might not get what you really want, so to say. We might not get what we really want because the data might not capture what we really want. And for such type of data, we need a very numerous data to actually capture what we actually want to give us the accuracy we want to get. So that's just it. So, but on the longer run, when we get, maybe we use a public data set and people are now using the solution, we keep storing new data. As it sees a new data, it stores it and it retrains itself. It adjusts the train. That's what they call transfer learning. So which adds more and more and more and more, and whereby the data set or the database keeps on expanding and expanding, which is in the case of ChatGPT. That's what it's doing, transfer learning. So, which means it keeps training and retraining itself based on the input of users. So that's just another thing. But if it would have been better if I don't know, maybe the bodies that are in charge of the data set, maybe in the teaching hospital, if there are things that can be done or things that can be signed, documents that can be signed that okay, the data will not be disclosed and this, and it's just only for social reason and to do this and this. So maybe that's the only thing. But using public data sets might not give us what we want. So that's just it.
Okay, thank you.
I hope your question is satisfied.
Yes, sir.
All right. I think we have Dr. Ayo Ajayi again raising up his hand. Okay. Any other question, please? If there's no question on these notes, I think it's high time we ended the class. So thank you very much for being with us from the beginning to these moments. I appreciate everybody for your time. Thank you and God bless you all.